Okay. Uh, Hello all. Welcome to another session of ST Scale System Design. And today we are going to do a narrated system design interview. And we have Navneet with us. Navneet, would you like to give a quick introduction what you and then we can get started?
Yeah, hey everybody, I'm Navneet. I have been attending SD skills for a long time. I think I got my current job because I participated into SD skills. I'm always grateful. Uh, I'm currently an engineering manager here at Amazon. Prior to that, I was at Microsoft, and I'm really happy to be here.
Awesome. Navneet, are you going to share your screen or something like that?
Yeah,
So we
yeah, I can share my screen. It's saying, okay, one participant. Okay, so I'm going to share my desktop and I'm going to be using a notepad for system
okay.
design. I will not use any drawing one because yeah, it doesn't work for me. Okay.
That should be fine.
Okay.
Okay, I'm going to post the question in the chat so uh, people also can take advantage out of that.
Which screen I'm sharing?
I think I saw your OneNote.
Okay, so my okay, cool. Okay, cool. Okay.
So I can see Untitled 15. Is that the one? It's a
Yes.
text pad.
Yeah, that's the one. Yeah.
Okay, awesome. So I just posted a question in the chat.
Let me see how I can see the chat.
Okay, I can put it in Discord, so if that is easy.
Okay. Yeah, that would be useful actually.
Yeah, I think just pinged you directly so you can get it from there.
I don't see that. Okay. So the question is this. So we need to design a distributed priority queue where a producer that enqueues items to be processed. These items can have a priority. A consumer discovers topics that have items. The consumer then dequeues items from those topics and processes them. If the processing succeeds, it acknowledges. If it fails, the items are nagged and will be redelivered to the consumer. Okay, so how I see that is, again, so a producer enqueues items in the to be processed, and these items have a priority. So can we talk a little bit more about the items or the messages? Like what's the size of these messages, at what frequency these messages are coming?
So right now, uh, think about message size could be really small. It could be like in KBs. If
Okay.
you want a size like 400 KB should be fine. So
Okay.
1 KB is also fine.
Okay.
And frequency, think like it's the pub sub model, and there would be a lot of producers and consumers. So there could be burst also. So a reasonable number could be uh, per second. There could be like 1,000 messages, I would say, and we can even go up. There could be burst of events also.
Okay. Okay. So now here, actually, like you said, it is a pub sub.
Mhm.
So can there be more than one subscriber for each topic, or can there be only just one subscriber?
So it depends how we want to take. Right now, I'm fine doing one subscriber to a topic, but in case if you want to scale, there could be multiple things also. Although it's a queue, so I'm fine one subscriber to a topic.
No, it's that what I understand from pub sub is that it's sort of a broadcast model, right? That the same message can be processed by multiple subscribers.
Yeah,
So is that true? Like one subscribe, like one message can be processed by multiple subscribers?
Yes, we can even go in that way. One message can be processed by multiple subscribers.
Okay. In that case, what is the like acknowledge versus NACT? Because do the message to be called successfully processed, all subscriber must acknowledge it, or only just one acknowledge it? Because again, there are, so in these kind of systems, there are three high level systems. One is PubSub, which is basically notification systems, right? There is one which is asynchronous based systems, where a message comes in and there is only one, like there are multiple workers, but only one worker works on one message at a time, and that worker either acts it or nacks it. And then there is stream processing, which is completely different. So I'm just trying to understand, because the number 2 requirement is kind of conflict with if it's a PubSub.
Okay, so I think let's make it for like one to one,
Okay.
always queue.
Okay.
So it can be simple.
Okay, cool. So so there's 1000, and it will not there will be burst, and then 1 to 1. Cool. Okay, and do we know, like, do we have an idea of how much time, like we are getting, let's say we are getting 1000 messages per second. What is the average processing time for a message?
So it's an asynchronous model.
Yeah.
So when you say the average time to process a message, like when it will be visible, do you mean? Because once it is visible, consumer should be able to pick it up. And
Yeah.
then based on consumer speed, it could take seconds, it could take a few hours. I don't know. Like,
okay.
What do you mean?
Okay, so wearing processing speed is minutes or seconds to hours. Okay, so does the message contain like the timeout as well? Like after which we should consider the like in case the processor doesn't X or NAX, because each message can be processed for hours. Does the message contain what's the timeout is, or how does we know?
So I think, yeah, that's a good question. So basically, think in that way, every message could have a visibility, and I think what you mean as a timeout. So once there is no acknowledgement, again, it will become visible. And that could be, I'm fine if it is configurable, or you want to take as a standard time for now.
Okay, cool. Thank you. Okay, so that's, let me see if I have any more questions. And what are the the system guarantees? Is it at most once processing or at least once processing?
So what do you think what it should be?
What from my perspective? So both the systems have differences. For example, in case of at least once, there is a chance where I can have a race condition, and two consumers can pick up, two workers can pick up the same message, and if one of them acts, I can do that. At most once means I need to guarantee that no two consumers or no two workers can process the message at the same time. So for example, for at least once processing, I can maybe use a database or whatever storage which is not ACID compliance. But for at most once, I need to use something which is ACID compliance. Let's go with at most once. Is that okay?
Yeah, I'm fine with the at most once also.
Okay, cool. So let's go with at most once. Okay, so now let us sort of create a in terms of storage. So if I'm getting say 1000 messages per second on an average, and say at the peak time, if it's going to be burst, let's say the burst is twice.
The burst will go from 10,000 to I think it can go 10 times.
Okay, it can go 10 times. Okay, so let's say, because when we design our system for peak. And so visibility timeout. So is there any guarantees that the system wants to do that once the message is sort of put into the queue, the message should be available to, if a worker is available, the message should be available to that worker, like it has to be processed in a worker in a certain amount of time, or no?
Yeah, so that's what up to you to pick up a visibility timeout where you think
Okay.
like your worker could be
Okay.
done the work, and you can decide based on stuff. There could be different ways for visibility timeout, and based on the race conditions, it could be in the start it could be 1 minute or 1 10 seconds, and then every time it could be can say, or it could be exponential. Like if the
Okay.
message comes back, we can make it invisible or something like that for more time. So
Okay.
based on different things could be done, but I'm fine making it really simple and considering like, okay, considering in 1 minute the message should be done, and you have considered this at most one, so I think then it should go hand in hand with that also.
Yeah. Yeah. Okay. So right now, what I'm going to be focusing on how I will design this priority queue
Uh-huh.
and workers and how the workers themselves scale and worker scaling. Let's consider that as out of scope of this question, because that can be a totally different system,
Yeah,
right?
yeah, let's not worry about that for now.
Yeah. Yeah. Okay, cool. So we are just focusing on the queue itself. Cool.
Mhm, mhm,
So now, given these things, what I was trying to figure out, and again, at a high level, I had, again, this is the narration part, where at a high level, I had a system in my mind
mhm,
for how I can design the priority queue, where basically I will have a set of messages, somewhere I need to store it, right? So here we have publishers, and then the publishers publish to a queue, and then there is workers, right? Uh, and the queue, because I have to have at most once, I need some durability, right? So now the durability or storage. So the question that I asked, actually, I asked to sort of narrow down my choices for each and every sort of stage. For example, when I asked about the size of the message, right, and the frequency of the message, then I was sort of calculating my storage requirements and my durability requirements. Uh, when I asked about processing time, initially I was thinking that I may have to focus on the worker scaling, but then given we are getting 10,000 messages a second and we may not have time to design the whole system, so I put the worker scaling out of the scope for this
mhm.
design, right? Um, so now I have a high level system. So now let's see if there are 1,000 messages that are being coming into the system per second, up to 10,000. Then generally what I've seen is for the systems that require asset guarantees, and when they need to write to the database directly and not to an in-memory cache, there is like a message, again in my experience, takes about 100 milliseconds to be written to the database for asset guarantee. Like if you use a relational database like AWS RDS or SQL Azure, they are generally slower databases than DynamoDB. So they take around 100 milliseconds to process a message. Means on a worker, in 1 second, I can process 10 messages. And if I can process 10 messages 1 second, then actually I need 1,000 servers to, as in my incoming servers, to hold this load, right? And if I need 1,000 servers, then I need to put a load balancer. Now, one question that I forgot to ask is, I assume that every message, it has a visibility timeout, and are all messages same, or do we have some sort of topics or separate queues?
uh, so so right now consider every I think when you say topic, like it should be one-to-one map with the consumer, right?
uh, kind of, yes, right, where let's say I have 10,000 messages coming per second, but these messages can be different for different topics, right? There could be 100 topics, there could be 1,000 topics.
Yeah, so think in that way, like every consumer would have their own topic where they will pick it up. So there is no clash between consumers. Is that you
Okay.
mean?
Okay. Cool. Cool. Okay. So now in terms of again high level architecture, this was my very crude architecture, and now how I'm going to revise this is that I will have publishers which are publishing the messages. Then I have a load balancer, and then I will have my application server, which are going to be in thousands. And these application servers, they are, so I will have two paths. One is the NQ path, and one is going to be DQ path. So here I'm talking about the high level architecture of NQ.
Okay.
So NQ, I will have publishers, I will have load balancers, I will have application servers, and the application servers will talk to a relational database like AWS RDS or SQL Azure. Again, both of these databases, again, they are their relational database, and they have ACID guarantees, right? So for that, I can make sure that I have the consistency is what I'm looking for. Right, consistency and durability, because we need at most once processing. If we don't need it, then maybe I could have gone with a NoSQL database like DynamoDB, where I get faster performance, but I don't get ACID guarantees. So what happens that whenever a user tries to enqueue a message, the publisher talks to the load balancer talks to one of the application servers, which can be in a round robin fashion, because here the size of the message and the kind of the message, they doesn't here we are not doing the processing, so all the requests are almost the same, so they can go to any application server. And for the peak, because I can get 10,000 messages per second, I'm starting with 1,000 servers, but I can have some sort of failover, or I can have some sort of an additional capacity, like I can have 1,100 servers as well here, so that I have a 10% more capacity in terms of requests that I'm processing, and they're going to write to the AWS RDS.
So this was your this part, right? Where publisher would send a message and you will write to a like a RDS or a SQL Azure database. But
Yes.
there would be more things to a message, like a metadata, which topic it belongs to, and other things, right?
Yeah. So all those things are coming from the message itself, right?
Okay. And just want to see circle back, like how about the product? Is the product you would also be part of that?
Yes. It's a prioritized queue, so the message have priority, right? So again, I'm not defined my data model yet.
Okay.
So that's the next thing that I was trying to work on, like what my data model looks like into my my relational database. But this is the sort of a high level data flow.
So this part was just writing to the database, right?
Yes, this part is
And,
just writing.
and I'm assuming, like in your next part, you would have more structured, like how the message would be organized, so and how the consumer can pick it up, right?
Yes, exactly. Yes.
Okay.
Yeah.
Cool.
That's going to be the DQ part, right? How they get the message. Okay. So now let's talk about the structure of the message. Like so, every message has an ID, unique ID, so it can be X and NX, and this is auto-generated ID by the database server, and then it has a body which is sent by the client, and the server doesn't parses it just gives it as is to the consumer, and then it has a visibility timeout. It has a topic, and it has a priority. Again, in this priority queue, and then these are the corresponding columns in my database. And in addition to that, I have some status columns, which basically says status could be a new or in progress or done. Okay. And then it has another column which says the last pick time. which basically says when was the message was last in progress. When was the message picked up by a consumer, a worker? Okay. So this is the enqueue part, and then enqueue puts the message into the system. And now let's talk about the dequeue part. So in the dequeue, consumer or a worker, whenever the worker is free, it polls our application, and it talks to a load balancer. And again, there can be a number of workers. So it's a, do we have in terms of number of workers that could be calling at the same time? Because we are not designing the worker scaling. So can I assume something?
Yeah, so you would have so basically at Mac at any time you could have let's say 1000 running queues or topics, how you take them, and then there could be consumers who are going to hit them. And average there could be 3 consumers per topic, which would be same.
Okay. Again, here I'm talking about the requirement for my application server. So how many worker requests per second will be made to my application server for DQ?
So there could be let me think. So you mean that how your worker going to poll?
Yeah. So whenever they poll, how many poll requests per second I can expect?
Okay, so that again depends. It could be configurable. Like they can pick one message or they can pick a batch of messages. Up to you how you want to take them. I'm fine taking one message at a time for now.
Okay.
And because there is so, and again up to you how you want to see that, because if I am assuming that if one worker has picked up a message, it will process that message. And if there are a lot of workers, like let's say for a topic there are 100 workers, then there could be 100 poll requests. So the workers, let's say the worker can go up to 100. I'm not thinking it will go more than 100.
Okay.
But
So
if you
let's
want to
say,
take a higher number, then we can even take like 1000.
okay. So let's say, assuming we have again, I'm putting some numbers back here in my numbers section, where let's say I have 100 workers per topic. 100 workers per topic.
But if a worker has picked up a message, then I think we already discussed, then because it's at most once. So the other worker will pick up another message, right?
Yes, yes. The other worker is like whatever the next in priorities, so they will pick it up.
Yeah,
so,
and we at the time we are getting 1000 messages.
Yeah.
So in that way, there would be 100 workers at a time. They can pick like 100 messages, right?
Yeah, yeah. Okay, cool. So here in this case, this is again on the right path for my database, and as we discussed earlier, generally 100 milliseconds per second is my experience, which says the application server takes to talk to and write something to my database. So I think in this case, if there are 100 workers per topic, and there are let's say these messages are distributed across the right set of topic, and if I'm getting 10,000 messages per second, so let's say to begin with we have 100 topics at a time that are active, right? So I can again get a 10,000 requests per second. So I need a similar load balance in my application server for my DQ as well. So around 1100 servers I will need. And they are also talking to AWS RDS or whatever SQL Azure.
So when you have 100, let's say you have 100 topics, right? Then every topic can have at a time like 10,000 messages. That's what you are assuming.
Oh, so every topic, no, every topic will not, like every topic will have 100 messages. So these 10,000.
Okay, so you're going in that way. Okay, I'm fine with that also. So every
Yeah.
topic would have 100 messages, and
Yeah.
then every topic would have 100 workers, right? That's
Yeah.
what you're assuming, right?
Yes.
And that means in every second, all that 100 messages should be picked up.
Yes.
Okay, Okay.
Again, and what will happen? The major difference here is going to be the number of application servers actually I need based on to the thing. And for what I'm thinking in now, when I have this requirement, I have this high level architecture. I'm thinking of using ECS Fargate as my application server.
Can you please circle back on this 1100 number on the application server?
Yeah, sure. So here we said that we will have 10,000 requests per second, right? And then we know that one request takes 100 milliseconds to process. So it means per second, one worker can process 10 requests. Okay. So one application server can process 10 requests per second.
Every application process can.
Every application server, if it's a single threaded, it can process 10 requests per second.
Oh, that's like you're assuming like one application can process 10 requests per second.
Yes.
Okay.
Right. And if I'm getting 10,000 requests per second, then I need 1,000 servers at minimum for peak.
Okay.
Right. And then I'm adding 10% capacity, which is 100 servers as buffer. Okay. And from the technology perspective, I'm going to use ECS Fargate, which is basically a serverless containerized application where I don't have to manage the containers. I can set a sort of a load balance, and I can say my it can be configured up to n number of servers, and as AWS takes care. Sorry, AWS takes care of scaling the servers. So with this, I have completely sort of a managed application stack where AWS RDS and Azure, 10,000 requests per second is very small amount for them. Like it's, I think they can scale up to millions of requests per second. So I don't have to worry about my database layer, and I don't have to worry about my application server layer because AWS themselves scales them really well. So in addition to that, in addition to NQ and DQ, the other system that I will have is basically, and again, these workers, they can either ACK or NACK, and I'm going to update the state of the column or the status column accordingly. And then I will have a watcher layer. What this watcher layer will do is that it will periodically query the topics and search for the messages where the current time is greater than last peak time plus visibility timeout. And if it finds any messages, it will put them back to new.
So this would be running on top of your database?
This watcher is going to be like, it can be a batch processor which is running. It will not, like when you say running on top of my database, it is another set of servers, batch processors which are running in background.
Yeah, but when you say query the topic, that would mean like querying, it would be you're considering that as a worker, or it could be like a offline job or a
offline job,
time job, which will directly go to database and do some checks and make things.
Exactly.
But how you will schedule that job? Would
How
it wake up every second, every millisecond?
Yeah, so what I can have is, and again, I can have a container that is running in background, which is basically polling the data for at a given intervals. Again, it will depend upon our guarantees, how soon we want the message to appear after the visibility timeout, right? So based on to that information, we can set the frequency of this watcher.
Oh, okay, but let's say every message has a different visibility. No, it could be same. Let's say they have same visibility timeout, but they could be, every message needs to be waked up after every second. Let's say one message
Yes.
came, it was having 5 minutes, then another message came. So you see, like every message, a sequence of messages could have a visibility timeout after every second. Then
Yes.
the job needs to be run every second. So that's what I'm trying to understand.
Yeah. So it depends upon our guarantee. Like for example, we can say the visibility timeout is the min time after which the message to be picked up. But we can
Okay.
have some sort of a buffer that after visibility timeout, a job can still stay in the in progress state for let's say 10 seconds, because otherwise my watcher is going to hammer my database.
So why not your worker when it is polling can do this job?
This worker.
Yeah, so basically when it polls, then you have application server, it will automatically decide like, okay, these messages are visible now, bring them in. It can do the same calculation. Why I need a watcher here?
Yeah, that's a good question. What I can do is that the query that I'm making here, I can
Mhm.
either check for the new messages or I can check where the timeout is expired.
And wherever it is, and you can, if it is picked, then you can give a new timeout to them.
Yeah, I think that's a good idea. Yeah, in that case, I will not need a watcher.
Okay.
Yeah. So in that case, I can avoid the watcher. That's a good idea. So here, when it is querying, it will either query for the new messages or query for or the messages where the visibility timeout is elapsed.
So yeah, but it would also look like done field, right? Otherwise, you won't able to give at most once delivery. Let's say if something is not done and if the visibility timeout is gone, then we don't want to make it visible for others.
Yes, of course, yes. Like when I say new messages or where the message where the
Okay.
visibility timeout is elapsed, because what will happen is that for the done messages, they will be yeah. So when I'm writing this query, I can write the query actually. Select star from my table where status is status in new in progress is new equal to new or status equals in progress, and I forgot what's the thing for the current time, but I can say last time
Mm-hmm.
plus visibility timeout is less than now. And I can say order by priority, and if it is picking one, I can say top one. And what will happen is that I will start the transition here,
Mm-hmm.
and then I will if it returns, I can update it. But actually, I can create a store procedure here, which basically picks up and then returns me the ID of the title. Okay, so I will create a store procedure which will take the first one. It will update and it will return the task ID, the message ID for the
So,
topic.
so here we are assuming that once the select part is done, so definitely it is going to worker is going to get that. So that guarantee we are going to assume here, right? So let's say worker tried to poll, we picked
Yeah.
up a message and then worker died. So so that means we are assuming that here that either worker die or able to successfully poll the message. We'll change this. We do the update on the
Yes. Yes. It's not that we are going to give an ID to the worker and then the worker is going to say, okay, now mark it as in progress. Whenever a worker queries us, we know that the worker is ready to start processing the message.
Okay.
Okay, but this was a good suggestion about this thing. I didn't think about it. I thought that I would need a separate process. Now, other thing that we need to think about is in terms of the database size. If you're getting 10,000 requests per second, then our database is going to grow too fast. And then, especially for the relational databases, the more rows they have, the slower they get. So we can have another set of worker, which is sort of a cleanup workers. What they can do is that they can move done messages to archive.
Okay.
Now, there is one more thing actually. Now I remember why I was looking at separate workers, because with this logic, what happens is the same message, it can be processed like say 1,000 times. Let's say if the message has a problem, it can be processed over and over again. So I need another column, in this case here is tries, right? Where it basically says how many times the message has been already tried, and I can have a max number of retries.
Okay, right? I think we never discussed about that, but that is a good suggestion, where we don't want infinite processing of the same message, and either it is a standard for the system or it's configurable. But yeah, good to have this thing.
Yeah, right. And so it can be either the message based or at a system level, right? So if it is a message based, then again it comes as part of the message. Or if it is a system based, we can just hard code it. So here we are going to basically say and tries is less than max tries. Okay, and then when we are updating, we'll update both the status, the last pick time, and tries. And then we'll have a cleanup worker. It will do two things. It will move the done messages to archive, or another thing that generally happens in these kind of queues is that we already have a dead letter queue, where every topic, it has some sort of a suffix or a prefix, which basically says for this topic, this is a dead letter queue. And then we move the messages which have surpassed the tries into the dead letter queue. Right, and we can have a separate table for dead letter queue, which looks similar to the current one. And this basically moves the done messages to archive and moves the messages that have passed their tries to DLQ, dead letter queue.
Got it. Yeah, we didn't spoke about that, but yeah, archiving or dead letter queue, I think both are good.
Yeah. Sorry, I should have clarified these requirements earlier, but I didn't.
I think that is fine. That is how I think progressively we build the system. Okay. Do you want to wrap this up by? Do you want to add something or wrap this up now?
I think like again, this question was simpler, and the shortcuts I took is that I used some AWS services like RDS and as well as ECS Fargate. So I don't have to talk about sharding, because these servers, they will take care of sharding by themselves, right? If you are not familiar with any of the managed services, then an interesting digression would be how you are going to shard the messages and how you're going to scale your database layer. Like you can.
So, sorry to interrupt you, but what should be the thought process when, like, let's say anybody who's seeing for the question for the first time, how they should progress this thing? Like, I think how you did, you went with the functional requirements first, right?
Yes.
And then And it's a classic example where you even didn't use any high level this sketchboard, but you are able to you're able to narrate your thoughts just using a notepad, and which is actually, and I've seen many people does, like many people able to do this thing without even using a like a drawing pad or something. So so how we should streamline ourselves, uh, like functional requirements and then telling your flow. Any tips around that?
Yes, I think like what happens is that generally like uh, all the system design interviews, they have very, if you at a 10,000 feet level, they have similar system architecture, right? There are going to be load balancers, there are going to be servers, there are going to be database. Basically, when I ask the functional requirements, and when I'm talking about non-functional requirements and these kind of math, when I'm doing, essentially what I'm doing is I'm filtering out and I'm sort of tweaking my architecture based onto these requirements.
Mm-hmm.
Okay, so for example, for database, I had choice of a DynamoDB, which is a NoSQL database, versus a SQL database, which is or relational database, which is RDS or SQL Azure. When I asked this question about at most once processing or at least one processing, I was figuring out, okay, which database I'm going to use.
Okay.
Right.
Mm-hmm.
When I was asking about messages per second, then I was thinking about, okay, how many servers I'm going to need, whether I'm going to need a load balancer or not.
Mm-hmm.
Okay. When again the same thing for the durability and the storage. The other thing is, when we were talking, like when I asked about the number of workers, right? And I asked about number of workers, and then I said, worker scaling is going to be a big problem in itself. So can I scope down my problem that is given to me, and can I discuss a part of it? Because then I will be able to focus. Otherwise, there are too many questions that I need to answer in the next 45 minutes, and it may not be possible for me to answer those questions.
So this is something like you already have agreement with your interviewer that okay, we won't go into this direction. So
Yes.
okay.
And sometimes the interviewer may tell you, no, I want you to basically solve that problem. And then actually it's a good thing, because now you know where the interviewer
Mm-hmm.
want you to focus on.
So that means we need to now split our time in that way that we should get time to solve these two problems together, right?
Yes, exactly.
Mm-hmm. Yeah, yeah, that is good. Like, yeah.
Right, because again, in every system design interview, the interviewer is looking for you, like for to see how you're solving a particular set of problems. When you are discussing the functional and non-functional requirements, your objective is to infer where you want to focus on. Otherwise, like system design takes like hours of time. And next thing, when I went into the solution, a good idea of your solution is to basically uh, uh, break down your system into some sort of a subcomponents, and then talk about components at a time. For example, here in this case, in my mind, I had systems for NQ, DQ, and actually I had in my mind system for the dead letter queue. So not the dead letter queue, but the reprocessing here, which got clarified, uh, and the cleanup worker. So what I did is that I basically described my solution into these three things so that I can focus on one area at a time. Because one of the things that I have done in past, and it's a mistake, is I try to solve the entire problem at once, and then I've spread myself too thin. But with this approach, what I did is that I broke down systems into multiple areas, and I was able to just focus on one.
Mm-hmm.
And in this case, the thing is, now the interviewer, I'm also sending a message to the interviewer that this is how I break down big large problems. Because system design, when interviewers are interviewing you for system design, based on your response as a candidate, you can either go into an SD2, SD1, or SD3. You will still solve the problem, but based on your response, you can be calibrated at these three levels. the more focused your answers are and the more organized your answers are, you basically moving to the next level. Right? And actually, there are few mistakes that I did, and now in hindsight, I should not have done it. For example, I should have clarified about the tries, number of tries, and I should have thought through a little bit more about whether I will need the other worker that I was needing or not. So there I went a little bit ahead, but then as the interviewer gave me a hint, I sort of recovered, right? And I addressed it. This basically gives a message to the interviewer that I'm listening, right? I'm a good team player, because design never happens in isolation.
I had a doubt. Can I ask?
Yeah, sure.
So how would we design if we had to take Kafka and use this priority thing? Do you have any suggestions?
So I have not used Kafka, but actually here in this case, we are designing Kafka.
Yeah.
Right?
Right. But with Kafka, maybe we will have a better response times. Like we have 100 ms for our relational types, right?
Oh, you're
I too
saying
haven't used
yeah,
Kafka, but I was reading about that.
Yes, so you're saying instead of AWS, RDS, or SQL Azure, I could have used Kafka as my storage layer?
Yeah, and Kafka by default does not offer priority, I guess.
Yeah, again, I don't have knowledge about Kafka. Yeah, I have not used Kafka, so I cannot answer about it. Like my experience with the databases are either DynamoDB or SQL Azure.
Cool.
So I didn't go
one
there.
other
Sorry, I just want to mention like anything related to technical thing. We would be here from 10 to 11 also, and we can check about that. Like if you have very specific how you do different in the system design interview, we can take tips from Navneet for next 10 minutes. What you say, Navneet?
Yeah, I'm fine either way.
Okay, okay, then fine. We have 10 minutes from Navneet, so yeah, we need to use that time in that way.
I have one high level question. So if we look at the problem statement, right, it talked about topics and all that. And to me, that got me into like thinking a little bit about Kafka and stuff. But if for anybody who, and I know that people attending this and preparing for system design, they're quite familiar with these terminologies, but what would be your recommendation, or how would somebody approach if you're not even clear about topics, right? So is that like maybe we should clarify, is that okay, right? Like to how much to ask about what topics are and an example around that?
Exactly, yes. And actually that's the mistake that I did, that I made an assumption of my understanding of topics, right? I think in hindsight, now you ask this question, I should have clarified what a topic means.
Okay, yeah, that's
right.
Thanks. Yeah, because I am not very comfortable with it. So for me, the first thing was, wait a second, what is topic? And I could see like, you or I'm sure a lot of people here know about it.
So Navneet, based on DP question, I have a follow-up question. Like say I got this question and I don't know anything about that. Is it fine to tell my interviewer, can he or she change this question?
So again, changing the question, it is basically on the extreme side. What you can, again, very well, but don't start from there. Start from where somewhere you can say, okay, can you tell me a use case of this system? Because I've never come across this. Can you tell me a use case of this system and how the system is supposed to work, right? Generally, as an interviewers, we don't give a question which is based on to some nascent technologies, and we see that not many candidates will know about it, because there is a risk that we are going to spend a lot of time in explaining the system to the candidate rather than focusing on the interview or their solution.
So Navneet, one thing, this in the requirement, right? These items can have priority. How have you used that in this
So how I used it is here again. I did a cheating where I used a relational database and I just ordered by priority, and I'm just choosing one.
Yeah, but if relational database is not there,
If relational database is not there, let's say if I have to use, so that's a good question. In that case, I will have again, I will not have the guarantee of at most one processing. Let me think how I would solve this priority thing based on to the. So okay, in no relation in the NoSQL databases, the only thing that we can do is that we can query using a key, right? So now I need to, and then we do the filtering at the client side, right? So basically what we do is that, let's say our key, our primary key for getting the messages is the topic name, and then I get all the messages, all the messages in this particular stage, like new stage or in progress stage. Like I can have my, okay, so how I'm going to design my key is it's going to be topic / status is can be my key, right? And then I'm going to say give me all new messages and give me all in progress messages, and then I will do the filtering at the client side, and then I will write it back to my database, and I will do the ordering on the application server. But then there is a possibility that the same message can be processed by more than one worker because I'm not holding any logs.
Yeah, I think there could be different ways we can do if we use a NoSQL, and then we can have this uh, different keys we can play around, sort key or this hash key, and then
So in this case, priority is based off status basically. Like in this question particularly, like things will be ordered in the priority order based on the status. Is that how it is, or is it like a priority could be like a user defined priority? I'm sorry, I mean this might be a naive question, but sorry.
Priority is the user defined priority. In the message, when we get, see here we said we are going to get the message body, which can be 400 KB, we'll get visibility timeout, we'll get topic, and we'll get a priority from the, yeah, the system doesn't define the priority, the user defines the priority.
and now in terms of fixating on RDBMS using RDS and SQL Azure, I kind of disagree to that. Like you can actually get high like even consistency with NoSQL also. So can you challenge my thought process?
I cannot challenge because most of my experience is actually in RDBMS. So I have very little experience with NoSQL. Basically, in a system design interview, there is nothing wrong or right. You need to say, okay, this is a system I'm comfortable with, and that's how I'm designing it.
Okay, yeah, that's a good answer. Like you're comfortable with it, but you should not say that this is the only way, right? This is say this is the way I'm familiar.
Yeah. Yes, exactly.
Because in the throughout the interview, you said multiple times that for having it almost once, I need to use this. You can say for almost once, based on my experience, I will use this. There may be other ways also. You should give that disclaimer.
Yeah, I agree. I could have used a better language. Yeah.
If we go with your approach for using a SQL database, my understanding is that there can be multiple workers who poll at the same time and update at the same time. How do you still guarantee that two workers won't poll and update at the same time? Are you assigning worker the stored procedure you said will be assigning worker the task, or the worker themselves will poll? And if worker themselves would poll, then there might be a chance that two people will get the same one, or are you going to log the entire rows?
Yeah, so here actually, I could have given more clarity here in case of like when I'm saying I'm starting a transition here. What happens is that in your SQL, what SQL Server is going to do at least is it's going to log this row. So once this row is logged, if in parallel another stored procedure is running, this row will not be available to for that worker to update it.
But it's not one row. You're saying select top one from table where so it's not one row. Whatever results that comes from that query, basically you're doing a select for update. You're selecting everything and you're updating that row. So all the rows that returns from whatever you have highlighted will be locked, not just one row.
Yeah, and that's where actually the I've already considered the 100 milliseconds for I think in hindsight I could have been a little bit more clear. That's why actually the SQL Server, the update and the select is slower, where because I'm locking all those rows. But in my understanding, actually SQL Server here, it will just log this one row which is it is returning. I'm not sure if it is going to
but it's not one row that it returns. You're selling top one from the table. Okay.
Yes. Yeah.
I see.
But I could be wrong. Yeah.
I know Navneet has a hard stop now.
Yeah.
Just one thing that is it a read lock or only write lock? When the write is happening in the work by the worker, can anyone read it, or it's a total lock?
It depends upon what. So there is I'm forgetting the term,
isolation level.
Yeah, isolation level that we can set, and we can say nobody can even read it or no one can write it.
Okay, perfect. Thank you.
Yeah. Sorry, I have to drop now.
Okay, Navneet, thank you so much for this. And we for others, we will be around and discuss. Navneet, would it be possible to send all this to me?
Yeah,
all your
I will
notes?
message you. I will message you.
Yeah, so I can share my screen and we can answer people question. But thank you so much.
Yeah, and thanks everybody. Really good questions. Actually, I got some really good feedback, and then if I see this question next time, I think I'm going to do better because of the sessions that you gave. Thanks a lot.
Thanks, Navneet.
Thank you.
Thank you.
So for others, Naga and I think other folks, we did this similar question earlier, where we did a deep dive on distributed message queue. So if you are interested, you can even see that video, and which is also good in that way. If you are not seeing this question earlier, so we went through really detailed way, and I see like a lot of questions around visibility, timeout, and other things. So we went in that video, we went through in like really detailed way. That's what I remember. But as soon as Navneet sent me the notes, he has sent me, and let me then share my screen to that.
Yeah, one thing I liked about the interview was there was which was different is there was no block diagram or anything, which was new. Like I never seen anything like only doing that flow charts.
Okay.
Yeah.
Can you see my screen?
Yeah, I can see like how the data will flow, like line 46, line 31, line 16, right? The flow is always in a text mode, not in the diagram. So people don't need to spend time on that. As long as he's able to explain that to the interviewer, I think that should be good. But one thing, the requirement for the question, I felt like I don't know if I got the requirement correctly or not. I felt like we were it was too generic, at least the distributed priority queue.
Yeah. So I agree with that. Sometimes the interview try to give really generic thing to see how the candidate looks, to clear the ambiguity, and how the candidate wants to deep dive into that. So it again depends who is your interviewer. Interviewer could give you really detailed requirements, or interview can give you like really ambiguous or very high level requirements.
So
I
I have
go ahead.
I have a quick question. Oh, thank you. I had a quick question. So, I mean, again, I'm still, I joined them, this session like about 15, 20 minutes late, but, it's still not clear to me, like when you do the deck queue, right, the deck queue operation, like in this case, are we saying that every time the consumer will read, right, from the queue, and let's say I want to, let's say a simple example, let's say I want to read something that is sorted by temperature, right? Let's say something like that. But my priority is a temperature value, not the the unique ID that is being added to the queue every time message has been enqueued by the producer. So it's still not clear. So are we, in this case, are we assuming that this worker will pull from the SQL table every time we query that? I mean, how will that latency will be 100 millisecond if I will have to read from database for all operation? Is this, can someone actually explain me? Because I'm still a little unclear on that aspect of it, from the consumer aspect of it. Like, do I have to like a query to the table database every time I have to read this message, like in a fast, like I guess in this case, it was like 1,000 per second, right?
So
the message is being queued.
So you think that latency should have been like divided between the publishing operation and the consuming operation, because like while publishing, we are just adding entry in the database. So that addition would take less time as compared to while consuming, because there is an order by in consumption. So that will have a higher latency compared to the publishing operation.
Mm-hmm.
does that answer your question, Prem?
So we are saying that we will, when we enqueue it, that's when we will actually sort based on the priority. Is that what you're saying? Like in this case, database will do that for me, like the ordering by priority. Like for example, database might create a secondary index when we are writing that and to the database, for example.
So in this particular design, from what I see, like in what we discussed in the last 1 hour, I think the way that he wanted to design this is that when a worker queries the database to get a message, when that query is running at that point of time, we sort of do the sorting. So basically, every request will do our order by. And
Yeah,
database does not create an index on its own.
Yeah. I think, yeah, if you see that query, I think that answers most of it. I think if you want to do the indexing, the columns on status and last pick time,
mm-hmm.
and the tries. So I think if you have there, like your select should be pretty fast. And
see. Yeah, I think that my only issue is that like if I have to do that every time, that
so
means I
I
will
think
be
it's a
locking the
fixed
database.
number of workers, right? Like you don't have more than 1,000 threads calling database at any point in time, because all you have is 1,000 workers. Each worker is going to query only when its job is done. So you don't have more than like those. I mean, like it's proportional, right? Like one worker can only process one job at a time.
Mm-hmm.
So it depends on how much processing time each worker will need to do before it pulls another one.
Mm-hmm.
So
mm-hmm. Makes sense. Yeah, no, I think it makes sense now. Thank you.
The other question I have is if your frequency is set to be 1,000 messages per second. So your database is pretty much going to be full of messages, like 1,000 messages per second times, let's say in one day messages comes. So into 66,000, whatever is that number. And having an index on the, you mentioned on the try status and last picked up time, that definitely will help. I didn't hear anything about sharding. He said like magically the ECS forgets or something. Forgets will take care of it. Is that a high level design okay to tell, like the ECS will take care of it and I don't have to worry? So because database is going to get full pretty much very fast.
No, but it is also getting cleaned up, right?
Cleaned
Because
up to
as soon as so it all depends on your cleanup job. So once the messages are done, they has to be removed from the database.
database. Mhm.
And one other thing we didn't talk about in the system, generally there's another property of a queue, how long it would be there. Like say you never come back, your consumer never comes back, and nobody's there to consume. So generally systems have, I know in AWS, SQS has max 14 days. I think by default is like 3 days, but it can go up to 14 days only. So they make sure that we don't have messages which are really old and nobody's bothering. So in 14 days you didn't read a message, that means they believe like you're not going to read it.
So how is this different from a normal table where I'm adding and polling?
Yeah,
Like,
I think the trick here is like if you define the priority, like you may have lower priority jobs hanging around for a longest period of time. So kind of starving, like not processed for a longer duration. So it's possible in this scenario because you are defining priority. If you don't have priority, it's most like whether it's a random order, like or the first come first serve basis.
uh,
Those are the
so
typical queues, right? Like that we have. So one is like we have FIFO, which is little hard to than the regular queue, which doesn't ensure like a strict ordering.
But also because we have 100 workers per topic, all the messages that were created might be consumed by every worker, and even the lowest priority ones might be consumed,
So
I
I think
guess.
yeah, we didn't talk about like the topic when we say topic, it's mostly pubs up, but like here I think we switch it back to one to one. So if you remember, like when you say
Uh,
yeah.
the
So yeah,
only
comes up
thing
again,
that
it'll have its own challenges. So I think Asim, is that right? Like we talk about like it's one-on-one, right?
Mhm. Yeah, so we decided to have 101, not one too many, because there is another requirement of acknowledgement, and they, so yeah, we went in that way.
I have a Uber level question similar to what the other person was asking. How important it is to talk about like partitioning and sharding in system designs? Because here I feel like we just said that like the existing technologies are going to take care of it, versus in other system design interviews, what we see is we want the candidate to design those pieces, like design like how my database is going to store it, like how am I going to scale if a queue has so many messages, even if it is maybe only stored for 14 days, but it can't be hosted in like one server if that queue becomes really hot and whatnot. So like those type of details, how important it is to like go into those things.
So in my opinion, Namita, that is actually important, but it all depends like how, what is your flow, and which how we are going to handle it. Let's say this was a classic example of a 40-minute interview or a 45-minute maximum. Will only get, I think, in most of them like 40 minutes. So in 40 minutes, how far we can go and how concise and precise we are telling us. Uh, and let's say when we're talking about databases, that time itself the candidate could talk about, hey, I feel that if we have a really big load, then what should I do, how whether I would need to do a regionalization, or whether I need to split it into multiple tables and multiple shards. So their interview, it's up to interviewer to go drill down that. But uh, but sometimes we need to be careful which direction I want to go. Let's say if you are not familiar with that place, and just to impress your interviewer, if I said some keywords that could also go against me, and might be interviewer is quite familiar with that. So I would say like go with your flow, and what is the actual need, go based on that. If something is not needed, like in this case, the sharding was not needed because the messages are not that high, and a SQL database can handle that many messages, and we are also doing a cleanup. So why should I bring an element of sharding and other things and make things more complicated? So I think there's one other principle which people follow, like KISS principle: keep it simple and stupid. So if it is something is not ready and I'm bringing that in, could also go against me.
Yeah, that's a great point. Yeah, thank you, Asim.
Yeah, again, like it depends on the interviewer. Like, yeah, if his focus was to test, then he would have dragged instead of focusing on like the separate flows, maybe just go in one flow and ask more questions about like increase like 1,000 messages per second to 1 million
1 million,
mess.
yeah.
Yeah, and then how would you handle? So, exam.
So it up to interviewer how he or she wants to take. Interviewer might be looking for an alternate design. Like, okay, this approach one looks good to me. This will work. What if it's a burst tomorrow? If my requirements get changed, what will be approach to your alternate design? So I think it's very much subjective to you and between you and your interviewer.
No, yeah, that makes sense.
So in my past, I've seen interviewer never bothered about scale. They just want to see how I think and how I break that problem. Because in 40 minutes we can't like magically do lot of things. So, and again, like Navneet mentioned in the start, they, again, it's good to see what is scope and what is out of scope. So interviewers should not drag into some other territory. So in this example, there could be a lot of other elements of surprise which interviewer can bring in, and we need to be careful that we either actually I want to solve it or just it is a digression from the actual flow. Although solving a problem with high level and other things are really needed, but these are like intangible things which also works like a charm. What exactly I'm going to solve, I should not get digressed in the middle of my interview.
Thank you, Asim. Hey, this is Manish. I got a quick question. I'm very, very newbie to system design. I would like to understand why there is a requirement to query the table when we are processing the message. I was not able to understand what it meant by at most once versus at least once concept at all.
Yeah, good question. I think I posted another link in the chat, so that might also answer this question. But let's go right away. So think in that way. This is distributed world, and you have a queue. Or think in that way. Uh, you are a family of four, and you have a queue where some supply is coming, and there are four people who can take that supply. And so at most one says, like, if one person has picked that supply, then others won't bother about it and others won't get it. But let's say we don't care about at most one. So supply came and four family of four, and four of them trying at the same time, they can pick that up. All of them might get it. So so and then if all four of the family members get that thing, then they have to handle on their side what to do now. Let's say for all four of them got the same chocolate, then they have to decide either they only want to eat one or they want to eat all four of them. But if I say I will only give one chocolate to family of four, then that means only one chocolate I'm giving, and then they don't need to bother about if all of them get the same chocolate, what to do. I just come up with some example
Great.
on spot of, because I was thinking about chocolate in the morning, so I just came with that example.
No, this is good, Asim. I think that really made it clear for me. Yeah, thank you.
So think in distributed world, there would be a lot of workers. Like when Navneet was talking about ECS, these days everything is containerized. You can spin same process multiple times, and so think about, you have a consumer I can spin it for 1,000 different instances. I just need to bring up 1,000 containers, and then they are talking to the same topic or queue, whatever. Then they have to decide either if I'm tell like, okay, I'll give all to all of you, then they have to decide what is the state of the system. Like, so if all of them process like message, then it should not disturb the state downstream. But if they rely on me that I won't give it to more than once, then they won't bother on their side. So it's between a trade-off whether my downstream would handle that or I would give it that way.
Yeah, and there is some like implementation overhead, like when you say at most once, because like you need to make sure like you don't need to send duplicates. But with at least once, I can process, I mean, like I may accidentally process the same message again, like, or like put the same message in the queue again, like there is a chance the consumer could get the same message twice. So you should have the, what is that, like I forgot that term. Gary, item potential. Yeah. So you should, so your consumer side, like when you're processing the same message more than once, so you should make sure that your system is idempotent. So meaning like it should have the same effect like processing on multiple times or even once. So
and more thing to that, even your consumer need to bother in some way that if you get some old message and you got a like say there's an item and you got an old message, then you even need to figure it out how to discard it. Like you already read the latest message on that item, but my system can send multiple times the old message also. That means my downstream system has to figure it out what to do. So it's a trade-off. Keep the queue design scalable. So if I don't need to bother about at most, then I can scale really well. I can pick up different technologies, and my downstream need to bother about this duplication. But if I need to do, then my system could go. The queue system can go in a different way. So there is a trade-off between who will do the work.
Yeah. So that's a great point. I think when we are talking about idempotency, a ID generated by auto-generated by the DB server could actually, eventually could result into the, data duplicacy, because now it doesn't know, right? Now, say database is generating ID. Once it gets inserted, the row is inserted into the table. But if the ID actually gets sent by the message itself, however many times that you send, it can only be like updated into the database only once. So does it make any sense, Asim or Naga? Like, can we say here the ID instead of generating it by GB? Can we also say that, okay, now like as a client, as a producer, I'm going to put ID to the message to resolve, to solve your data duplicacy issues, even if you have to. Also
depending on the domain, like you normally tend to use something like customer ID or whatever, or like if you have an end-to-end flow like across many systems, then you have like maybe a global transaction ID or something which is ensuring this. So yeah, it depends on the domain and what systems that are already existing. So you have to, I mean, like I think this is part of the guy who is defining an end-to-end architecture or like the specific system which makes sense best for you. That's what you're going to use it here. So if you're processing for a customer, like, or an order, or like a product ID, or like it could be anything. It depends on the domain. So what is that unique ID which you want to say, like, if I get the same request for this same again, it means the same. So something like that. So
thank you, Naga.
Okay, is there another question? Or if you're good, then I can stop the recording and then.
Asim, I have a question. This is Shiva.
Sure.
Asim, this is a overall the requirement point of view or solution point of view. he given the breakdown, but I'm not understanding the architecture point of view. Which could be the dealing queue or in queue, how the interaction is happens. My worry is using the NQ is also 1100 application server, which is in NQ as well and also DQ as well, DNQ as DQ as well. So how it is the cost efficient solution is making in terms of the introducing number of instances and
So
architecture also I couldn't see
yeah, so
where the worker is fits, where the NQ flow fits, and where the DQ flow fits. Because it's
so
in Notepad he made, but I couldn't.
So actually, it would be a good idea. There should be a visual graphic for this thing. I would recommend if any one of you is attempting, always have a visual graphic. That actually helps even for you and for your interviewer. But let's say, but this style is also, I won't say that this is also. I don't say that. Like I discourage this idea because I've seen people in the real design sessions in the company, they go in this flow. But for an interview, better to have a visual graphic where you can say like, okay, this is my this and this is how it will interact with other components. Specific to this thing, here I think the candidate made an assumption that, okay, the messages won't go beyond that and these many reserved instance should be fine for that. And which is also you kind of a standard thing in the industry where you know the limit of your system, then having reserved instances is not a bad idea. But if it needs to scale, then we need to think about a different approach. How if my load is less, I don't need 1100 servers, I only need 100. If my load is more, I need 2000. Then there is different technologies like containerization these days, which scales really well and fast.
Correct, but the requirement when he is capturing, right, he making the 1,000 servers are for both incoming and outgoing. I think the maintaining, but he maintained for NQ also 1,100 and also DQ for the 2,100. It's a
Yeah,
total instances he's using almost 2,200.
yeah. So he made it like a really separate system, but it could be follow question to him that, hey, do you want to merge them? But I think it's good to have both systems independent and don't have overlap.
Correct, correct.
I have a question actually.
Mm-hmm.
This is Ganesh. Actually, I'm seeing this for the first time. So, the detailed design of a topic or similar to Kafka, but I'm not aware of the Kafka as well. So the basic question is like does the who publishes the topics and stuff like that, is it out of scope for this? That is first question. And second, I was imagining that maybe we will need to have a priority queue, something like an in memory for the better latency and stuff like that. And also, like, for the third question is about for the subscribers, right? So is that like how do they subscribe or something like that? Is it out of scope for this in this problem as well?
Yeah, so in this problem, that was out of scope. And who is the publisher and who is the subscriber. But if I would be the candidate, I would just very high level, I will touch upon when I'm doing a high level diagram. And even I can share my screen like you remember I was telling about this video.
Okay.
Here.
Because I'm not sure whether the topics here were predefined or something, and then subscriber
Yeah,
just.
so if I would be in that position, let me jump forward this video. And if you see in this video, we spoke about there would be like a admin service where you can do all admin activities and just left it there. That's it.
Okay.
Don't, if I would be doing this, I would, because in microservices world, I would talk about this would be my admin service, this would be my write part, this would be my read part. And that's what I would have taken that. And I think somebody asked about this question, about the visualization, then I would be done. So in any problem, if you get, whether it's this one or this, if you think something needs to be done with metadata, just say like there would be a metadata or admin service and which you do, I and you can ask your interviewer like, do you want me to go deep dive into this? I think our main focus area is on the right and read part. And your interviewer say, yeah, I don't want. Okay, it's good it is there, but I don't care about it. But you tell your interviewer that you give an impression that you think about the microservices world, where every feature could be its own microservice. Does it answer your question?
Yeah, I think kind of, yeah, because I mean, I had some kind of an assumption or understanding how that will be, but I'm not sure like the subscriber, whether that will be like something like a webhook or something that they provide, and then the worker will DQ the message and give it to subscribers.
Oh, so you mean the communication from a consumer to the application server?
Yeah, that part as well. Like, how does the delivery happens?
So there are different technologies. There, it could be like a request and response. It could be like a long polling. So we might not be able to cover in detail right now, but I'm just giving you things.
Okay, but those are out of scope of this, right?
It depends. Let's say at the end, if I would be a candidate, once I'm done, I would do one full-fledged run through of my system. I'll say there would be a publisher which will go to the admin service, which will create its own queue and then define all the metadata. Then it will start posting messages. Messages probably could be like a REST base. It will just request and response, send a message, get acknowledgement, be done with that. It will go to the DB. Then the consumer, once it comes, it will register. It will go to a read. Then probably it could be the request response call, REST based call, RPC call, long polling. And then once it comes, it will give it. Once it is done, it acknowledge. It couldn't acknowledge. I won't clear it from here. So at the end, I would try to give like a high level flow, and wherever they are going to talk to each other, I would try to give some understanding how they will talk.
Okay. Asim, meantime, right? You showing the workers will where exactly it will place in this diagram.
Workers is kind of this consumer.
It's a consumer end. Okay.
Yeah.
Okay.
I think workers will be this second box, right? The down one. Is it read?
No,
because
worker,
consumers
let's
the
say,
external, right?
is the thing. So worker was this who is going to read the message, and then this is application server who is talking to the storage.
So worker is a kind of a consumer.
Okay, consumer. Okay.
Yeah, but like it's a different terminology. Somebody can call it consumer, somebody can call it worker. Even this could be called as a worker because it is doing some work. So
okay. But one more thing is talking about the scheduler, right? Scheduler or something. So we made out of scope, right? Where exactly it will come? Is it within the DB or some daemon process or scheduler will be?
Which scheduler?
Yeah, he making something job schedule or something he was mentioning in the solution in the previous discussion. You made out of scope that one.
No, this was a scaling part of the worker.
No, another one is there.
Cleaning job. I think it's a cleaning job. So
this one.
Yeah, that's going to be a scheduling batch job.
Yeah, so I think if you go in this video really far enough, somewhere down, we would also talk about.
Okay, details are there. Okay.
I don't remember now. It's been a while. We did this, but if it is there, good. If it is not there, there's always like you can talk. There is offline workers, or there are workers which will wake up at some time and then we do this. I don't remember if we spoke about that. Let me go really more into this. I think we are mostly talking about the read-write flow. I don't remember whether we, and I think we put a lot of ads.
So what was the specific question? What was the
information?
Sorry.
I mean, like, I'm just trying to understand the specific question about that batch job. So,
I think I think this is a question. Clean up worker batch job.
Oh, what type of batch job you do?
Yeah, how?
So now, I mean, like batch job is something that it periodically like wakes up and.
Correct. Where exactly it is doing actually? It's I understood what is the batch
Oh,
job.
okay.
Where
You mean
exactly it
like
is you are
from where
doing
it's
it?
cleaning up? Yeah, it's going to remove the messages from RDS database and put it in your any whatever the archive storage that you design. If you say S3 or like S3 Glacier or and like if you want cloud storage, or you can say it could
Correct.
be your own
You are putting it
organizational
into some
file.
storage. My question is how you are executing that daemon or scheduler. How you are executing? Is it in part of your DB itself? You are creating a schedules, or are you creating in the your application server, or in instance you are placing some writing in some code and you are handling those to push into your storage.
Yeah, I think it depends again, like it's again another bad job design, right? Like it's again, you have a lot of flexibility on how you want to handle. So my preference is to be have an external bad job,
Okay.
which queries or like do, or there could be like if database has support for it, like why not use that itself. So either one should be fine, but like again there will be pros and cons for both approaches, so you pick according to what makes sense based on
Okay.
that. Mhm.
Okay. Thank you.
Hey, I have one question. He talked about the containerization, right? To bring up the workers to process the messages. So how exactly it plays now the containerization here? Does it make sense?
The I mean like the containerization, the I mean like right, like how the ECS thing, like how it comes up, like you don't have a lot of overhead of spinning up Docker containers, like for the jobs. Like if you need to scale, these systems are already like they have built-in mechanisms to scale based on load. So it can spin up in, you just define the configuration, what type of worker instance you need if there is some more load. So it knows like given the current workers are not able to process the outstanding messages, the like in this case, like the Fargate, I think, which he mentioned it, I think it should automatically spin up new instances, and those instances will be same like existing running instances, so that it can like assuming like all of them do the same job, so they'll be able to spin up in new instances and like process, like consume the messages and process.
Sure.
So
To maintain certain kind of consistency in bringing up the worker nodes available, right? Yeah. So just the regular containerization concept. Okay.
yeah, I mean like I think you can, yeah, if you want to deep dive on containerization, like you can, it could be this AWS Fargate based, or like some other Azure, like if anything that you want, like you can also deep dive on that. And if you want to present in this forum to the group, that will be good learning for as well. So again, this is a community driven, so yeah, it'll be, if you are interested, I think it makes sense um, to learn. Anyway, you're going to learn, and if you want to present, come back here and present as well, that will be fine. If not, like take some time and come back as well. So
Sure. Thank you, Naga.
Naga, one question. So nowadays I'm checking in YouTube your ST videos, but we couldn't find recent, mostly couple of weeks system design videos. Is it uploading or how it is? What is the plan, Naga?
yeah, I mean like we don't have people processing the videos, like it's kind, since it's volunteer, somebody actually looks into the video, and they do some pre-processing, like add notes and stuff. So if you would like to be part of this volunteering community, like let me know. Like you yourself can listen to these videos once or twice, make notes. So it's kind of, it'll helps you in the learning, and you can publish on behalf of ST Skills to the YouTube after its process. So since like whatever the existing volunteers were busy in their day-to-day work, so if you are interested, like let me know, ping me or Asim. We can get you we can get you access to this YouTube videos so that like you can process and upload them.
Sure. Basically, I have to record and I have to download and then
no, all of the recordings are already there, but like we just, instead of uploading the raw video, we just add some titles and other stuff. So it's those small
modifications required.
Yeah.
So,
sure, Naka. I'll ping you then. Yeah.
Okay. Yeah.
Okay, I'm going to stop this recording.